All right, good morning, everybody, and welcome to the SIG-OpenStack Intro and Deep Dive. Now, this is an 85-minute session because we've combined both the introduction to what SIG-OpenStack is doing and the kind of work that we're doing, as well as the deeper dive and more of a work session for people who want to become involved and contribute to the different projects that fall under the SIG-OpenStack governance. So thank you for coming. My name is Chris Hoge, and I'm from the OpenStack Foundation. I'm one of the co-leads of SIG-OpenStack. With us, we also have Aditi Sharma from NEC Technologies, who is one of the co-leads, as well as Christoph Glavitz, who is from InnoCloud. For this talk, we also had some additional contributors. Liangjing Hong from Catalyst Cloud, who unfortunately wasn't able to be here for the summit, but he contributed to this slide deck and has been a very active contributor to the cloud provider, as well as Thomas Hartland from CERN, who is going to be talking about the new autoscaler work that has just landed within the organization. So the way this is going to work is because SIG-OpenStack is so broad and expansive, we're going to kind of start with the introduction and then an intro to the individual projects themselves. And at each time, we're going to take a break and open it up for questions. And so if you have anything that you would like to know more about the things we talked about previously, you'll have an opportunity to do that. When you do ask the question, either please, we have a handheld mic that we can pass around, or say it loud enough so that I'll be able to repeat it so that people who watch the video later on will be able to hear what the question is. Okay, so just to start off with what is OpenStack? OpenStack is programmable infrastructure that lays down a common set of APIs on top of compute, networking, and storage, and resources that are related to that. And you can think of it as one platform for virtual machines, container, and bare metal. And it's actually like almost any other cloud that you would have out there, with one of the main differences being that it's entirely open source. And so whether you go out and choose to run applications on one of the many public OpenStack clouds that are out there, or run OpenStack on your own infrastructure, or have someone run it for you in some sort of managed infrastructure, you know that you're going to get the same set of consistent APIs and that it's all open source. It's supported by a worldwide community of developers. So if you kind of look at the application layer here, we have at the bottom we kind of have this like networking, bare metal, and storage, which consists of the very basic services. On top of that, we build different sort of compute engines that take advantage of all of those. So Nova for virtual machines, as well as bare metal containers with Zune, and containers as a function with Keenling, as well as other applications that sit on top of that. One in particular that is of interest to this community is Magnum, which is it's essentially an application orchestration installer that includes Kubernetes as one of the target systems that it will install and allow you to manage. And it winds up being a fantastic way to have tenant-isolated, managed Kubernetes on a shared cloud resource. OK, so what is SIG-OpenStack? The SIG coordinates the cross-community efforts of the OpenStack and Kubernetes communities. And there's actually a SIG that's within the OpenStack community called SIG Kubernetes, which consists of the same people and has the same aims. And so we are really trying to build cross-community efforts and build as much collaboration as we can. Because one of the things that the OpenStack community really believes is that we are very successful when we collaborate and when we build infrastructure together. And make it open for everybody. But when you break this down, there are a lot of different ways that these collaborations can happen. The first is that if you treat OpenStack as a deployment platform for Kubernetes, and so, for example, this comes up with Magnum, but it also comes up with other installers like Kops or KubeSpray or the new Cluster API project that's being managed through SIG Lifecycle. so you're treating OpenStack like you would any other cloud, like you would Google Compute or Azure or AWS. It's a cloud. You want to run applications on it, and you want to run Kubernetes on that cloud to deliver the applications. But it can also be a service provider for Kubernetes. And so this is the instance where you might want to have an identity provider that lets you manage users for your Kubernetes cluster. So we have hooks to bring in keystone authentication. Or you might want to use the Cinder storage provider. So Cinder gives you an API that can be backed by over 70 storage engines with a CSI plugin that allows you to run it with any cloud that you would want to run with. But it can also be a collection of applications to run on Kubernetes. And so in this case, we're kind of inverting what's going on here. And this covers projects like OpenStack Helm and Airship, where you're putting Kubernetes down on bare metal, on your bare metal infrastructure, and possibly linking that in with some other OpenStack services, and then deploying OpenStack on top of that as a cloud. So this diagram kind of covers all of those use cases, where we start at the left and we have OpenStack Ironic. For those of you who were at the last community meeting or at the Open Infrastructure Summit, we actually gave a demonstration of a custom resource definition with Kubernetes that integrates with Ironic to put down bare metal. So you have collaborations between Kubernetes and OpenStack at the very bottom of your stack. Moving on to the infrastructure layer, where you're doing your OpenStack installations or your Kubernetes installations with network overlays that are managed between products like Calico and Courier. And then your cloud, where you have a full set of cloud APIs available, including things like OpenStack Magnum, where Docker and Kubernetes are linking into the cloud with various shim layers like cloud provider OpenStack or Courier and Calico. Okay, so what are we working on right now? Kind of the major things that are happening inside of the Kubernetes community are the cloud provider OpenStack. And so this is the software that allows a Kubernetes cluster to talk to and take advantage of OpenStack resources that are available. And this includes the implementation that is for the Cloud Controller Manager, but also a number of things like a CSI driver for Cinder. This also includes a cluster autoscaler, which is for autoscaling Kubernetes clusters on OpenStack depending upon load demands, so that you can start an application, and if the application starts demanding more resources, your Kubernetes cluster will automatically grow within your OpenStack cloud to accommodate that need. As well as the various cluster deployment tools and lifecycle management tools like Magnum, the cluster API provider OpenStack, COPS, and the cluster API provider for bare metal with Ironic. So with that, that kind of ends our first section, which is just the very high-level introduction and overview as to what the SIG does and the things that we do. And so at that point, does anybody have any questions right now as to what the SIG does and kind of what our scope is and the activities that we're involved with? OK, no questions there. So now we're going to bring Aditi Sharma up onto the stage. She's one of the co-leads of SIG-OpenStack, and she's going to talk about cloud provider OpenStack. Switch up.
Hello. Yeah. Hello, everyone. So it is the cloud provider OpenStack. It is in the Kubernetes ORG GitHub repository. And this subproject hosts various plugins so that we can leverage various OpenStack cloud services. So first one is the Cloud Controller Manager. That is the cloud provider interface implementation for Kubernetes. Second one is Cinder CSI plugin. And we have Ingress Controller also. We have a Key Manager service and Keystone authentication and authorization. We will see little about each plugin in the next slides. So as I said, Cloud Provider OpenStack is the implementation for the cloud provider interface. So Kubernetes needs various information from the cloud, like information about zones, node, and all these details. These details are fetched from the OpenStack through this plugin, that is Cloud Controller OpenStack, and it is essentially a CCM binary, Cloud Controller Manager binary. So the second one, we have the Octavia ingress controller. So it is a in Kubernetes ingress resource can be configured for external access to services, load balancing and filtering, etc. So it is less expensive than creating an IP per per service. So basically, Octavia Ingress Controller has been developed by Catalyst Cloud, and they are also using it. The next one is Cinder, the CSI drivers. So we have a file system-based driver and a block storage-based driver in OpenStack, that is Cinder and Manila. So we have the container storage interface implementation for both of them. So in Kubernetes, all the entry providers, all the entry volume drivers are going to be deprecated, and they will be replaced by the CSI ones. So we are currently working on CSI and CSI drivers. So the Manila CSI driver, that is still in progress one, and in Cinder CSI driver we have, I think, released we have 2 or 3 releases of Cinder CSI driver. So the next one is Keystone Auth and Client Keystone. So like Chris also said, you can manage your Kubernetes cluster users via the Keystone plugins. So we have 2 plugins that works together. One is the Keystone Auth, and another one is Client Keystone. So like the second one, Client Keystone, it allows exchange of user credentials with the bearer token via kubectl. The next one is the Barbican KMS plugin. It is in very basic stage. So it provides the encryption at rest service. With your the Barbican service running in your OpenStack cloud, you can encrypt your your Kubernetes etcd data. So this plugin is also currently in development. So yeah, so we have we have a getting started guide, and we have lots of works to do in this sub project. So that's it from my side on Cloud Provider OpenStack sub project. Anything you want to ask? Yeah.
Yeah, it's okay. You can ask.
Thank you. I was wondering how the migration story from people that have existing clusters that use the entry OpenStack provider to the external cloud controller looks like.
So the migration story for that is you essentially have to restart the Kube API server. And it's tricky. So you restart the Kube API server and you set the cloud provider to be external, and then you bring up the external provider, and then you restart the API server again, and it will hook in to the cloud provider. Now, the primary issue with this is that your API server will be down for either some amount of time, or if you have HA API server, how that manages the leader election can be a little bit problematic. SIG Cloud Provider realizes that if you have a running Kubernetes cluster and you need to perform this upgrade, that there may be some additional tooling that has to happen. And so that's an active sub-project within SIG Cloud Provider, which is finding a migration path for how you transition from the in-tree provider to the out-of-tree provider. And
so I think the question more pertains to... So I think the question more pertains to the file formats between the in-tree provider and what data needs to be given, and what is being expected by the out-of-tree provider are totally different. They require different pieces of information that isn't available or required in the in-tree versus out-of-tree? Like, how do we go as, not so much as a, like, how do you make this switch, but if I have 100 clusters, how do I operationally, and I mean collectively, we have thousands and thousands of these clusters, how do we move from, you know, XYZ format to the out-of-tree format and, you know, put that data there in a consistent fashion so that we're not all just magically building some scripts to do this for us or magically building some tooling on our own 1,000 different times for each of us.
Yeah.
I understand there is a synchronization issue, and I think we can sync the in-tree and out-of-tree provider. So we can develop, like for Cinder, like for the CSI plugin, what we are doing, we are exactly using the same configuration parameters that are being already used in the in-tree one. Right. So same things we can do for the cloud provider code also. We can bring them in sync. Yeah.
Yeah, and that's, you know, if that's, you know, if there's common tooling that we need to develop, then the last thing that I would encourage anybody to do is to figure that out on their own. We have SIG meetings on Wednesdays, which are in the morning for the US and for the afternoon for Europe, which you know, that's actually, I think those are work items where we should prioritize that, because the people who are running production clouds and need to make sure that those stay up are, you know, as we make this transition, and this transition is going to be happening in the next, like, it's going to be forced in the next 9 months. You know, we need to make sure that we're taking care of the people who are using this in production, because if we're not serving you, then we're not meeting the mandate of the SIG. So yeah, that is.
Okay, maybe to expand a little bit more. I mean, the one thing is having the API server temporarily down. That's not ideal, but that's okay. But a different problem is, for example, there are kubelet flags for the cloud provider. What are we going to do about that? Should we like take down all nodes and then restart them? That's a problem.
Yeah.
Did anyone already think about this?
Well, cloud provider is thinking about it, and
I think that is the problem in general with all the cloud providers.
Yeah.
So what is happening? There is another SIG cloud provider. They are trying to find a common solution for all the cloud providers to upgrade their clusters.
Yeah, and it's, I mean, it almost speaks to the general problem of upgrading Kubernetes clusters in general, is how you, I mean, you always have this problem. It's not. Yeah. So, yeah, it's something that SIG-OpenStack is going to have to solve specifically, but that SIG Cloud Provider is looking at generally. And I know that for the folks who are in Europe, that this time is really difficult. Thursday afternoon in the US, we have cloud provider extraction meetings where this is one of the central topics that we talk about. I can look into having that meeting moved to an earlier time, so that there can be wider participation from you know, because I know that a lot of the OpenStack clouds are running in Europe, and you know, we want to make sure that when we work out the solution, that the solution is going to work in production for everybody.
So to recap how we are doing it, we're currently implementing this to migrate to the cloud provider and also migrate to the CSI Cinder plugin. We are restarting the API server and the controller manager, and also restarting all kubelets to use the external provider. Have some migration to create the CRDs for the CSI stuff, for the existing attachments, and yeah, that's partly it.
And are you finding, are you having any troubles when you restart the kubelets? Has that been an issue for you?
Not yet. We have to look that the cloud provider registers then the provider ID, so the node gets ready.
So you don't have to restart the entire node, you just have to restart the kubelet?
We have to restart a kubelet, yes.
Okay, yeah. So the question is what tooling are you using to do that?
A self-written Go in this case. Lots of client Go.
Hi. Do you have any kind of estimate on when we should be switching to the cloud provider interface, and when we would the entry thing?
So, so that's a good question. So we have code in place that is going to we have a patch in place right now which removes the provider. It's one that DIM's prepared and has been ready for about 6 months now. It would need to be rebased and reworked because a lot of entry work has happened that has gone to extracting the providers. We've been deprecated for about a year now. Based on the feedback that I'm hearing right here, and so one of the things I was going to work on was bringing that patch up to speed and having that in, so the code was removed this cycle. But if we're not ready for that, then the feedback that I'm hearing from this session is that we might still want to clean that patch up and make it ready to go, but make it land directly after the next release so that we have one more release where everyone can prepare. And then we have a solid 3 months to make sure that the tooling is in place and that the common practices are in place. But in general, you should be ready to you should have migrated by KubeCon San Diego. And so that's the hard deadline that SIG Cloud Provider has been setting for all the providers, and that's what we're targeting. The pace has gone a lot slower than we've expected it to, so you never know if that's going to be the case or not. But I was, that was it. I thought people were further along in moving than they were, which makes me happy to hear that you're here telling me this, so that we don't move too fast on it. Okay, are there any more questions about the SIG Cloud Provider? Yep.
All right, hey, just a couple of things. So the entry cloud provider handled load balancers as well as storage.
Yeah.
But then with the CSI and the ingress controller, does that mean that this is going to be handled now by those two components and it's not going to be in the Cloud Control Manager, or is Cloud Control Manager going to be using those under the hood?
Yeah. Yep, thanks.
Yeah, load balancer is there in out of tree, but there are no volume control loops, and there is nothing related to volume in the out of tree cloud provider. This is in general consensus from the Kubernetes community. So there is so CSI is different. There is no relation between the external cloud provider and CSI. So yeah, you have to deploy it separately.
Yeah.
So, and one thing more on the CSI part, the whole cloud provider and the SIG's cloud provider and SIG storage community is trying to figure out how to deploy CSI driver on clouds. So that is in progress.
Yeah, and that's, that when you look at the documentation for, I think it was like 1.6 when they implemented the Cloud Controller Manager and broke away from the Kube Controller Manager, where it was a conscious decision that because of CSI that the volume control loop should be handled independently. But you're seeing this a lot too, where you can actually set up a lot of these control loops independently. And so the Secrets Manager is in the Cloud Controller Manager repository, but it's a separate it's a separate interface and it's a separate interface and application. Similarly, we have an Octavia ingress controller which can run separately. So you should, it's a matter of typically looking at what is most important for your cloud. But as of right now, I think the only thing that we don't implement in the OpenStack Cloud Controller Manager is zones, and that's because it's very hard to find two clouds that have federated their identity, and so zones don't make a whole lot of sense. Now, if there are a lot of OpenStack clouds, and I know that within the research community that is happening, it may make sense also to start looking at adding zone support so that we can start building clusters across multiple regions and taking advantage of those facilities. But that's really the only thing in the cloud provider we haven't implemented yet.
Regarding the load balancer support in the new cloud provider OpenStack, will it support neutron load balancers, or do we have to move to Octavia?
You're going to have to move to Octavia. Actually, LBAS v2 was 2 weeks ago. The Octavia team and the Neutron team finally took all of that code out of tree. And so if you're staying up to date on current OpenStack releases, LBAS v2 is going to disappear. For my own personal experiences with working with LBAS v2, it has some pretty serious race conditions that Octavia doesn't have. So I would suggest that you move to Octavia anyway. One of the complaints that people have about Octavia is right now it's pretty heavyweight because you basically need to bring up a virtual machine for every load balancer. But it's my understanding that the Octavia team is aware of that problem and they're actively working on solutions. So we should see improvements on the number of resources that are required for Octavia load balancers coming up in the future.
Yeah, in the plugin, we have the support for LBAS v2, but it is deprecated.
Yep.
Yeah.
So we had a question here.
The problem with deprecating LBAS v2 is that some of the SDN software, like OpenContrail, still implement that version, right, of the API, and doesn't support Octavia. So I guess the best case for me is to stay on the original cloud provider.
Yeah, I mean, so the question is when are you it's a matter of on your OpenStack cloud how are you managing the upgrades on your OpenStack cloud? Because at some point, if you stay close to the current releases on your OpenStack cloud, eventually you're not going to have LBAS v2 support anymore. You're going to have to, if you want that, you're going to have to backport it in. And so it's something that it's deprecated, which means that it may not have support. Pardon?
Just call Juniper and ask them to implement Octavia support.
I mean that should be. That would probably be the path forward. I mean, for right now, you're going to be fine. A year from now, it's going to be a lot harder. Yeah. Yep. Okay. Are there any more questions on this topic? All right, then we're going to move on to the cluster API provider OpenStack. And Christoph Glavitz is one of the principal engineers on this project, so he'll talk about this project.
Hello, everyone. I just want to give you a quick introduction into the cloud provider OpenStack, which is Joe Bida talked about that on stage already. What we are going to achieve there is to have a central place where we can define how the clusters and the machines are going to look like, and that's not specific to OpenStack, but we have an implementation for OpenStack so that you can, with the same set of APIs, you can bring up a cluster on OpenStack. And it's a very fast-paced development currently there. We have many things that happen in the cluster API upstream project, what we need to keep up with, so developers are always welcome. And we are hoping that we can share forces with all the other cloud providers to get to a point where we have the right layer of abstraction and just configure the specific parts that we need for the specific implementation. So in short, it is we have the server running in the API server as a custom resource definition. You create how a machine is supposed to look like. A controller kicks in, brings up the machine, installs everything on top of it, and that's totally independent of the cloud provider. We implement this part for OpenStack, but it's totally independent. We also have a bootstrapping mechanism so that locally on your machine, likely, or on an existing OpenStack where you deploy everything to it, the controller kicks in and on a Minikube, for instance, creates the OpenStack components for the control plane, and then pivot everything to that, and then that takes over, and your Minikube cluster is going to shut down, and everything else is managed on the running cluster you have. Then we have a couple of more primitives, not just machines. We also have machine sets and machine deployments, which are very close to how deployments and replica sets look like in Kubernetes. So you can just create a machine deployment of, let's say, 3 nodes. And in the background, the control loop kicks again in, creates 3 new nodes, connect them to the API server, and then you have 3 new nodes. You can even have different configurations for separate deployments so that you have some nodes with GPU in it, some nodes where no GPU is in, whatever you need, We are very open to that. Under the covers, so we implement the cluster API v1 alpha 1 currently, and we test it with Pike to Rocky in the OpenStack versions. We didn't have tests for Stein as for now, but that's going to change in the future. And I don't expect any huge problems there because the APIs that we are using are stable. The only thing we can't go down to an earlier version than Pike. That's not possible because we use APIs that are not there yet. We support Kubernetes 1.13.5. Also nothing before that because of some things in Ubuntu repos, and for sure the 14 release. We have in tree some examples, so it's not technically not supported, but that are examples where you can start from for CentOS, Ubuntu, and Container Linux. The available bootstrappers are Kind or Kind, Minikube, or an existing cluster. I recommend to use Kind, Kubernetes and Docker, because it starts up very fast. Then you spin up your OpenStack machines and pivot and shut that off. And the entire project is also used in the OpenShift installer. They currently use a fork, but they also contributing heavily back. So how you start usually is for contributing, or even for trying that out. You can go to our GitHub repo, check that out, install the cluster control command, and then you need to generate a couple of files. Those are those example files. There are so many parameters you can tweak so that we can't provide a canonical way of doing stuff. And as I said, it's just like every other Kubernetes manifest. We have those provider spec that's important. And everything that's underneath the value is specific to the cloud provider. So what in there is really specific to what we need on OpenStack. An AWS thing would look exactly like this, except for that values is going to be different. And you need to change some things like the image name you want to use, SSH username you currently need, key pair to access the stuff, maybe availability zone. You need to give it an OpenStack network so that that you have networking in your VMs, and probably a floating IP. That's primarily important for the control plane component, but not for nodes. So on nodes, you usually don't do that. Just do it on the control plane. And then you can just create the cluster. And this is seriously just bringing up a Kubernetes locally on your machine, installing the cluster YAML, which is just a short configuration like the pod sider and the service sider, putting the machines. This is what we saw here. This is one of them. This is a list of machines technically. We see one here. And the provider components. Provider components is something we generate, and there's everything in we need. All this is committed or posted to our cluster, which runs locally. The control loops kicks in and does everything to bring up the cluster on OpenStack. In the provider components, we also define the user data of the specific target we have. Like if it's in Ubuntu, we inject a script which uses kube control underneath and brings up the entire machine. Same for CentOS. It's also just a script in this case. For container Linux, we're using the container Linux configuration, which is compiled into Ignition internally. But nothing keeps you from changing that. So if you decide you want to have another distribution, or you don't want to use those scripts we provide, you can at any point write everything you can pass into the user data of OpenStack. So you easily can write a cloud config, for instance, if you like to, and can change it to your specific needs. Yeah, and we're always happy to have new contributors to the project, for sure. Like I said before, we are working heavily on the cluster API currently, the V1 Alpha 2. There's much discussion happening there, so this is the channel for that. And we have our own separate channel for the OpenStack-related stuff, so that we can coordinate quite a bit better, because the cluster API Slack channel is so full of all the people around the project, and it was hard to coordinate for a specific provider. So some of the providers have their own channels like we have. Just jump in, ask questions, and I can speak for the entire SIG here. There are no dumb questions, just ask questions. We try to answer that. If you don't get an answer, maybe try it once more, because people are sleeping and are not able to come up with or to follow everything that's happening there. Just try it again. And even if it's not related, we are happy to point you to the direction where you need to go. So just ask us. We will respond. Yeah,
and this is a tremendous opportunity for collaboration with the SIG and with the Kubernetes community in general. For those of you who were here during the contributor summit, the cluster lifecycle SIG meeting was completely packed and full of people. This is solving the problem of how you install and maintain clusters is something that the Kubernetes community in general is turning a lot of their attention towards. And although there are a lot of different tools out there to accomplish this, more and more of them are adopting the tools that are being developed within cluster lifecycle and moving towards this kind of Kubernetes API-centric cluster API approach for doing things. And so, although there are a ton of toolkits out there that work great, in my mind, it's pretty clear that this is the direction this is going in. And I think that there is, because the API is not even complete yet, if this is something that you're interested in, it's a great area for collaboration and contribution. Especially now, it's a very good place to start on the Cluster API project, because there are so many discussions around that and how we want to shape the API for the next versions, because we learned a lot in the last couple of years. There's a question over here. We have the first question over there.
I'm sorry if I missed this early on. What's the relationship between this work, if any, and the stuff going on with Airship? Okay.
So the question is, the relationship between this work and Airship that's actually something that is, I wanted to make sure that we added onto this because I think it can get a little bit confusing. There's also a bare metal cluster API implementation that's in progress right now. That's starting off of some efforts that kind of came out of Red Hat with their work on OpenShift, but is turning into a larger community bare metal effort. Now, their machine custom resource definition is backed by Ironic. And so there's a lot of interest from the OpenStack community to work on, to work on this. If you go and you look at I gave a keynote at the Open Infrastructure Summit a couple weeks ago, and I also gave a demonstration at the Kubernetes community meeting on how the implementation of the machine custom resource definition. So you can go and see those, but essentially there's going to be one of the bare metal implementations for Cluster API is going to be backed by Ironic, and Airship. Right now, Airship is using Mass as their bare metal deployment tooling, but they're going to be transitioning to using Cluster API bare metal, and so they're going to be contributing to this. And recently at SUSECon, they announced that they're going to be adopting Airship as their cloud deployment tool. So that's going to be part of SUSE Cloud 10. So they're also starting to to participate and contribute in the bare metal Cluster API driver. So it's another place where SIG-OpenStack is definitely interested in that because it's using Ironic as essentially one of the kind of the basic underlying driver for that. And it's another place that if you want to get interested, there's a lot of work that's going on, and a project that really started out as like a Red Hat centric thing has suddenly become a much broader community-oriented project, and the development's moving really fast, but it's really cool. Having used it hands-on and used the machine actuator, it's pretty neat to see how when you issue manifest to Kubernetes with the CRD, it just does all the right things for Ironic, and your machine comes up.
So in theory, we can deploy everything that has an API for deploying machines, no matter what machines that are.
Yeah.
If that are virtual machines or bare metal machines, everything that has an API could in theory be operated by some machine controller, which needs to be implemented.
Yeah.
We had a question here in front.
Here and then here.
So what happens with Magnum once if this effort,
Yep. So, I mean, I think that is largely up to the Magnum developers. I think that we have some of them here. So Magnum's mechanism for managing Kubernetes is largely heat templates. And there's been a tremendous amount of work put into that, and it's stable work. And just because one implementation exists doesn't mean that another implementation can exist and can exist side by side. There might, I think that maybe that some of the Magnum team, and I can't speak for them, but they may have looked at the Cluster API as something that can replace the custom templates, or maybe they integrated into the heat into their heat templates so far. But right now, Magnum it's in heavy production right now, and the important thing about Magnum is you can think about the Cluster API as, in some ways, it's a user-facing API where you show up and you give it your cloud credentials, and then you launch a cluster on that cloud. Magnum is also a user-facing API that's doing a lot of work behind the scenes, and there's no reason that Magnum couldn't switch to something like the Cluster API behind the scenes. The important thing is that the Magnum API stays the same, so that when a user shows up, the same commands that bring up a cloud will continue to work across future releases of it. So the primary answer to the question is, ask the Magnum team, but having one doesn't preclude the use of the other. Oh, here then. Oh, sorry.
So one thing, preface, I am one of the maintainers of Cluster API provider OpenStack and a Cluster API developer. I've been working on it for about 2 years when it was named something completely different. We will be changing the name as well. We made that decision as part of the contributor summit. The core thing to remember about Cluster API is Cluster API right now is in a very dynamic state, but it is the goal for Cluster API to become the definitive way to deploy Kubernetes clusters. We've got hundreds and hundreds of different ways across the community where we've built KubeSpray and Magnum, and that's just like two things. You've got COPS, you've got GKE, you've got all of these different things that are doing the same thing. We want to, we've fractured out enough that we can see where most of the APIs need to be, what those APIs need to look like, and we're bringing them back. So regardless of what the tooling is that's going to be using it, whether that be COPS or Magnum or Airship or something else, Cluster API provider OpenStack, the underlying tooling will eventually be expected, not necessarily required by Kubernetes. We're pulling more stuff out of the core. There is less stuff required, but it will be expected by the user base that you will have the machine primitive there just as much as you will have the pod primitive there. And it is expected that all of the tooling will eventually use the same APIs and provide the same user-facing APIs to do that. Whether you want to use Cluster API provider OpenStack or Airship or something else to do that, as long as it makes sure that it provides those APIs internally to the user, who cares?
And one advantage we have, or you have as a user, you can deploy to any OpenStack with the Cluster API provider OpenStack. You just need to have compute, networking. Yeah, I think that's it. Maybe a load balancer.
Right,
and you don't need to have heat deployed or something like that. You just have to have those core services running.
Right, and there's a you might want to differentiate between a cluster that you own and you build and you have, and Cluster API is always available to you. If you have access to a cloud, you'll have access to the Cluster API because you make a choice to stand up that Kubernetes cluster and how you manage it. It interfaces with your cloud, and it's just how you stand it up. If you are using someone's managed Kubernetes API, it's very likely that people are going to start moving to Cluster API to manage that anyway. But when you're using a managed Kubernetes cluster, you may not have access. One of the features of that is you actually don't care how that cluster is established. You just know that you ask for the cluster and it's given to you. But having that be on your managed cluster is probably the way that you're going to ask for more resources and upgrades and.
So the expectation is that cloud providers, regardless whether they're managed, unmanaged, etc., will provide you with those primitives, because that's also how we'll eventually. The goal is to do things like autoscaling,
upgrades,
and doing upgrades. Also, it's very, very easy. If you haven't tried it out, one of the coolest things that you can do is scale your entire cluster by doing kubectl scale, machine deployment, -- replicas 100, and now I've got 100 machines in my cluster, and I haven't. Yeah, if assuming you have the quota to do that. But that's. It's now literally as easy to scale your cluster as it is to scale a deployment, and we want to give that power to the users and make it very simple, regardless of which cloud provider you're sitting on. I don't care if you're sitting on GCP or OpenStack. I prefer you sit on OpenStack, but at the end of the day, it's about providing this transparency to the user and saying, just like we're saying with storage and compute and everything else, let's democratize it and let's give everybody the same set of primitives to be able to use to manipulate that infrastructure.
All right, I also have a lot of questions about bare metal deployment. Like, I've tried MetalCube, and so far, the main idea behind it, so I have these primitives that we've talked about, like a bare metal host I create a machine, it triggers a machine actuator, which creates a bare metal host for me, and then it becomes the Kubernetes node.
Yeah.
What actually deploys the Kubernetes node, and is it in scope of Cluster API? Because right now, as you said, there are a lot of tools like KubeSpray, KOps, or whatever. Am I supposed to just prepare an image and configure it with metadata API or something like Cloud Init, right? Or
so-
what's the deployment engine basically behind
Yeah.
it? Because I understand like the
So-
ironic and I call OpenStack API, but I actually need to put config and binaries onto the node.
Are there any Metal Cube developers in the room right now? Because so, what I do know is that right now they focused on the machine actuator, which is come along very nicely. They don't have the cluster actuator isn't in place yet. So the tooling that they're using for that, I don't know. I imagine that there's going to be tooling to facilitate different deployers, and so I would imagine that something based on CoreOS is very early on the roadmap for that. But I think that because there are so many different interested parties, that it's going to have some sort of pluggable architecture where you can pick your precise deployment method. So the answer is I don't know.
On OpenStack, we just use, in the case of Ubuntu and CentOS, we just use a bash script, which is just injected as user data. And for the container Linux part, we are using a container Linux configuration, which is also just passed in as user data into the OpenStack VM. And under the covers, for installation, we use kubeadm. But that's also totally up to you. You can, even when you use Cluster API provider OpenStack, you can inject whatever user data you like to. And you can either use a prepared image, you could use your own cloud config, you can spin up the control plane VM with systemd instead of using kubeadm. That's totally up to you. So we are very pluggable in this case. And one more thing, because Jason talked about the autoscaler, one idea behind the thing is, currently we have autoscalers and we have cloud provider specific code in the autoscalers. Like the autoscaler needs to know about OpenStack, about AWS, about GCP, and so on. And if we are successful with this project and have those primitives of machine deployments and machine sets, the autoscaler needs to implement just the cluster API part. And all the cloud-specific heavy lifting under the covers is doing by the machine actuator, which is running anyways. So in theory, we could potentially remove some code out of autoscalers in favor to just talk to cluster API and does the specific implementation doing the rest.
Did we have any more questions? One over here.
Hi. I don't know if it's related to the same subject exactly, but beginning of the talk, it was mentioned that OpenStack can help you to handle the multi-tenancy on Kubernetes. So can you expand a little bit on how OpenStack can facilitate managing multi-tenancy in Kubernetes?
And so I didn't hear the question entirely. What was?
So can you expand a little bit in how OpenStack can facilitate managing multi-tenancy in Kubernetes or setting up multi-tenancy for Kubernetes?
Did you understand?
Yeah, I didn't understand.
Okay, how OpenStack helps us to facilitate multi-tenancy.
Oh, multi-tenancy, right,
Kubernetes.
right. So so essentially, when you stand up a Kubernetes cluster inside of an OpenStack cloud, you're giving a user a tenant, and OpenStack Neutron, as well as the other projects, have strong ideas of multi-tenancy. There are a number of ways that you can be configured, but largely that the software-defined networking component of Neutron makes sure that all of your network traffic is segmented. You can also implement stronger or weaker policies on the nodes to, co-location or other things. But essentially, because OpenStack is multi-tenant, when you give someone an OpenStack project, any cluster they run on that is going to be isolated from other Kubernetes clusters. And
so maybe the answer is having more separated, smaller clusters than having one huge one.
Right. So you don't have a single Kubernetes cluster that is multi-tenant. You have lots of small clusters, one for every user, that you know is guaranteed to have isolation from the other clusters.
Hi, can you hear me?
Yeah.
Yeah. So it's rather like a multi-tenancy with separate clusters, but inside of the clusters, then you don't have like a namespace as well. For instance, controls.
Right. Nothing like that.
No.
Yeah. I mean,
you can authenticate against Keystone, so you can have your users in Kubernetes as well. But it's up to you to write the correct roles and role bindings to permit access.
Right. Yeah. Running like a Kubernetes cluster is a Kubernetes cluster, and one of the goals of things like the Cloud Controller Manager and the Cluster API is that you as a user, once you've launched your Kubernetes cluster, it's a Kubernetes cluster, and you treat it like you would any other cluster, and the machinery that you use to manage that is the same. And so if you want to set up RBAC, so that you can control, so that you have namespace control and user access control, you can provide that. The OpenStack, the SIG-OpenStack also provides tooling so that you can hook in Keystone to that. And so if you want to have an individual cloud and then have RBAC managed through the Keystone project user model, you can do that. Yep.
Hi. So does it work also if you have your Keystone that is taking the authentication via SAML or OIDC in a third party?
Yeah. So
for the Cluster API part, it in theory works, but you must customize it because you must pass that configuration to the API server, and we don't have templating at that point. So you must reconfigure the script and pass it to the provider config. But it's in theory it's possible totally.
Okay. So were there any other questions on the material we've covered so far? Okay, we'd like to invite Thomas Harland up from CERN to talk about the new cluster autoscaler for Magnum work that he's been working on.
Hello, I'm Thomas Hartland. I work at CERN, and I've been developing the cluster autoscaler cloud provider for Magnum. It was just mentioned earlier, but when I say cloud provider, I mean only the internal part of the autoscaler, which provides the interface between the autoscaler and the scaling APIs of the cloud. My work was just too late for the autoscaler 1.14 release, so it will be released with 1.15, but we did already work to include it in the Magnum Stein release. So you can already use it if you have already upgraded by setting this label at cluster creation time. The manual deployment isn't difficult at all, so on older versions you can still do that. There are example files in this repository here, in this directory, and you only need to change a couple of things. In the deployment, you need to give the cluster name or ID of the cluster the autoscaler is going to run on, and you set the maximum and minimum size that you would like the scaler to scale between just here. And you should set the maximum size so that your cluster cannot overrun the quota limits of the OpenStack project you're in, because it is not aware of the quota. You also have to give credentials for authenticating with OpenStack, and you can either copy these from a cloud config file on one of the nodes, or just fill in the values yourself. And there is also a service account, which is in another file, and you do not need to modify that. So you create these 3 files, and then you're up and running. When you create some pods, which request more CPU than there is available in the cluster, the autoscaler triggers a scale up immediately it takes a short while for the nodes to be provisioned, and then once the nodes are available, your pods can then run. Once your workload is finished, you delete the pods, and after a short delay, the autoscaler will remove the nodes that are no longer necessary. Now this is all well and good, but if I'm creating and deleting the pods myself, I could be resizing the cluster myself. Instead, you should use the horizontal pod autoscaler, which scales the number of pods in a deployment to the amount of workload, either by the CPU usage of the pods or by a metric that the pods expose, such as number of requests per second or the latency of the responses. So once you have the number of pods being scaled to the workload, then with the cluster autoscaler, the cluster is also scaled to the workload because it scales based on the number of pods. The last point on this slide is that the autoscaler can shuffle around pods if they are not being used, if the nodes are not being used more than 50%. By default, so you should be careful when using this with stateful workloads, as the pods can be deleted. You can disable this, though. At the moment, the cloud provider for Magnum is not yet feature complete. We're waiting for a couple of new features in Magnum. In the Stein release, there is the cluster resize API, which gives more control to Magnum of how the cluster is scaled. And in the train release, there will be node groups for Magnum. These enable different node types, sizes, availability zones, and different hardware of nodes in the same cluster. And these node groups can be independently scaled based on which pods want to be on which nodes. For more information, we have a blog post you can look at. This has some more details about the autoscaler and about what CERN wants to use it for. And there is also the the SIG autoscaler deep dive session this afternoon. So I think that's it now. Are there any questions?
Well, so now we have kind of two projects, right, to spin up Kubernetes clusters with OpenStack. One is Cluster API, and second is Magnum, right? How do you see them? Are they going to converge, or one is going to be deprecated by another?
I think SIG autoscaler is hoping for the cluster API, because that will mean that a lot of the internal cloud provider inside the autoscaler can then be removed in favor of just using one API for all different clouds.
So the cluster API is the way forward, basically, at the moment.
Yeah, I mean,
pretty much, yes.
Yeah, I would look at the cluster API is not, it's still alpha, right? Still in alpha, so if you use it today, you can expect changes, you can expect it to be unstable. 1 year from now, you can expect it to not maybe be entirely implemented across some providers, but 1 year from now, you should be thinking about how you are going to move your deployment tooling to cluster API, or whatever, what's the new name of it?
We haven't decided yet.
Okay, they haven't decided on it, but
yeah, so cluster API.
The project formerly known as Cluster
Yes.
API.
The project formerly known as KubeNode, formerly known as KubeDeploy, formerly known as... Oh God.
Sorry. I walked in front of the speaker.
Formerly known as Cluster API, is going to be split into at least 2, maybe 3 APIs to define worker machines or machines. Potentially, we haven't decided yet, but are working this out. The control plane machines and the cluster as its entirety, because we've kind of recognized that we actually are trying to represent several APIs with, or several identities of things with a single API, which isn't great. But Cluster API will become the definitive way under the hood for the actual deployment and actual management of the machines. Cluster Autoscaler will be able to get rid of most of their code. And the reason we're doing this is the exact same reason as that we're moving to the cloud provider. It's that people like, really good example here in Europe is Exoscale. They're a really small Swiss provider that do fantastic work, they're awesome, but they have their own API. For them to get any kind of code into Autoscaler is almost impossible, because that's all controlled essentially by Google, AWS, and somebody else. I can't remember who the, Azure might have some stuff, but there was somebody, oh, VMware. So getting any kind of code merged into that, or getting any kind of in-tree providers merged into the kubelet and Kubernetes as a whole, like just doesn't happen anymore. We needed a better way to do it. So we're extracting all of this stuff out. Cluster API will become the definitive way to address the cloud provider from an infrastructure side of things, not from a load balancing side of things or a storage side of things, but from an infrastructure side of things. And then we can start ripping out all of the code that represents everything else. So we are in alpha. That means that our APIs will change. Some of the providers already have guarantees about their stability. Cluster API provider OpenStack, we are certainly not stable. Please do not use us in production. If you're developing on it and you're really, really crazy, then maybe you can run it in production, but it certainly caused me a lot of pain, so probably don't. But there are providers like the GCP provider and the AWS provider that say, hey, come use us, we're stable enough to do this. So it really depends on a provider by provider basis. The big thing about Cluster API is it's all about the API. The API will change. The stability of the provider is dependent on the provider, and whether that be a kube spray to provision a control plane with some machines under the hood, or something else, like at the end of the day, it's the same API that you're going to use to interact with the machines once you have the cluster up.
And we are certainly not here to replace Magnum, but and we are not implementing a button where you can click on and you get your cluster, because we already have that. It's called Magnum. So we are hoping that they will keep up with our development, and in a future release of Magnum, we maybe also have a provider for Cluster API. And we're not here to replace Magnum in any ways.
Okay. Question over here. And to follow up on that, one of the nice things about OpenStack is there's a pretty strong commitment to keeping APIs stable. And so, regardless of what Magnum uses as its deployment mechanism, there is going to be a period of time where if you're depending upon Magnum and you're depending upon the APIs, that there's going to be stability on that, so that you don't have to think about it as an either or. If and when Magnum goes to using Cluster API as its implementation of how it deploys, probably the biggest change that you're going to see is an improvement of the API that's available to you directly through the Kubernetes cluster that's provided, as well as the API provided to you through Magnum. So it's I think it's once you start thinking about projects in terms of the APIs they provide and less about the underlying implementation of it, you start bringing a lot more power to the users, and to me that's one of the advantages of having something like Magnum API and having a Cluster API is that they don't become mutually exclusive one another, because you're focused on the APIs rather than just a direct implementation.
Cool, thanks. I've got a question about your production readiness. You're telling me maybe in 9 months, a year. But how come Red Hat is using it in its OpenShift installer? So I'm waiting for the OpenStack installer for the new OpenShift 4 version. And they're planning it for a July release. So how's that possible? I'm sorry? They are not.
Yeah, so the answer is that it says they aren't. I mean, OpenShift is actively developing on this, and I don't have a lot of insight into what they're doing internally for their OpenShift deployments.
But in the beginning of this presentation,
yeah, but they're doing. But it's but that would, I mean, if you're on Red Hat, I would talk to your Red Hat team about the implementation details of it.
Okay.
They're actively working on. They're active participants in both the bare metal and the OpenStack Cluster API implementations. But I like. Definitely, the bare metal one's not ready for production, and the OpenStack one isn't either. But that's not to say that they're not going to be ready a year from now. And also the thing to keep in mind too is that production ready means different things to different people. Production ready may mean that you have to wait for your preferred vendor to package and support it, and that is always going to lag where something is in the development cycle. In the development cycle, it's typically stable long before it reaches production within your vendor, and so so much of that depends upon. So you need to be watching the developer community and what's happening at these events and at meetings like these, and also communicating with your vendor and saying that I've heard about these things. When are you going to support it so that you can plan your own roadmap for it?
And the installer is a specific kind of thing that they bring up some OpenStack VMs that are afterwards not necessarily managed by Cluster API. This is the part I wouldn't try today because of the stability, but bringing that up, bringing the VMs up once with an installer, then you just freeze the code at a certain point where you know that you can bring up VMs and connect them together, and in this terms it's stable enough.
Sorry, I missed the question about OpenShift and OpenStack. Can you repeat that for me?
Yeah, I can hear you. Yeah, OpenShift on OpenShift on OpenStack.
Yeah, what was the question that we were?
Oh, if he was what the question was what the it sounded like Red Hat was using the Cluster API to deploy OpenShift.
Okay.
On OpenStack, I don't.
No, I can tell you more or less from the high level. So Red Hat is I'm from Red Hat.
Okay.
Disclaimer. We are working on an installer, the OpenShift installer, which uses the Cluster API among other things. It uses the OpenStack provider, and we're planning to support it before the end of this year, and yeah, we believe it's pretty solid and ready to go in production as soon as we release it. Currently, if you check the releases of OpenShift, soon we are going to release OpenShift 4.1, and we are planning after this release to support the installer on OpenShift. On OpenStack.
Okay. Thank you.
Thank you for the answer.
Okay. Any more questions? So we have just about 10-15 minutes left. On the rest of the talk, we have some items, some housekeeping things. Some of the achievements we've had in 2018. We've deprecated the entry provider. We've talked about this at length. We're doing testing of integrated testing of OpenStack, end-to-end testing on top of Kubernetes on top of OpenStack, and that's being reported to the CNCF CI/CD, as well as reporting end-to-end testings back to TestGrid. Magnum is a certified Kubernetes installer. That certification is going to run out in a few weeks, but we have Mohammed Nasser at VexHost is working on re-upping that, so we should see that certification continue into the next year. as well as implementation of the Cluster API, and the publication of the OpenStack and Containers white paper, which that's a little bit out of date and needs to be updated because this ecosystem changes so quickly. But if you're interested in seeing that, which contains some of the things we talked about earlier, that is something to take a look at. We have also covered a lot of our plans for 2019. And functional testing improvements for all the drivers is on our list. So if you want to get involved, we have a Slack, we have SIG-OpenStack, as well as SIG Cluster API, OpenStack, SIG, and a Google group where there's a fairly low volume mailing list where we communicate also. If you want to join our meetings, they are every other Wednesday at, I think, 1500 UTC. So we skipped this Wednesday because of KubeCon, and we'll resume next Wednesday, and then every other Wednesday after that. And so what we would like to see is there were a lot of awesome questions and people who are very invested and interested in the work that's going on here. We would love for you to come to the meetings so that we can get you involved in the work that's happening, and we can make sure that we're focusing our efforts on the things that the community needs at large, and also get the community members more involved with the day-to-day development and more active in being part of the community, because the number of people who are active in SIG-OpenStack is pretty small. But the reach is also fairly large, and so we would like to make sure that we're growing the developer base, and pretty much all contributions and all feedback are welcome. That's what we're here for, and kind of like the primary thing that we want to accomplish.
And for the transitioning work from the in-tree to the out-of-tree, we understand that many people have a lot of problems, but we are also lack of developers, so we need more contributions from our users.
Yeah. And also, for those of you who are interested, we're going to talk, if you're interested in cloud providers themselves, I'll be giving a talk later this afternoon, going into a few more details of how you start building a cloud provider and just kind of an introduction on where the code is, how it works, the things that are expected to be implemented, and some tricks for how you test and and some other implementation details. And so that is going to be happening this afternoon at, let's see, what time is that happening at? That's going to be at 2:50 in 8.0 C2, so just right next door from here. So any final questions before we wrap up the session?
So I have a question about Autoscaler. So we are not using Magnum, but are deploying Kubernetes on OpenStack. And the work that has been done with Magnum Autoscaler is very interesting. And I would like to know if there are chances that this work can be used outside of Magnum.
Yeah.
So the autoscaler is structured in such a way, or at least the Magnum cloud provider. In development, it was called the OpenStack Autoscaler Cloud Provider, but then we changed it because it was only for Magnum at that time. The structure is such that there's a kind of OpenStack general layer in the cloud provider, and then there are different managers possible that can call different APIs. So, for instance, once the node groups and the resize API are available, that will be a separate manager, but we'll use the same OpenStack authentication from the kind of the other layer of the cloud provider. If you wanted to use OpenStack with something else, you could write a different manager that would also slot in and provide its own interface.
And Thomas, does it? I assume that the OpenStack Autoscaler depends upon heat being installed on your cluster. Is that right?
For the specific manager that I have written so far, yes.
Okay.
But if you wrote a different manager, it's not necessary.
Okay.
Anyone else?
Okay. Well, I want to thank everybody for coming, and and we're always happy to answer your questions offline or at the meetings. Thanks everybody. It's really great to see this turnout and this level of engagement.